Now we're going to go through and fill out this last foldable here, or the next foldable, and permutations and combinations. So first thing we're going to do is fold it up and cut it apart. So we're first going to talk about permutations. So a permutation, it is a set of objections in which order is important. So order is important. There's actually specific slots that we go through. So permutation is the choice of R things from a set of N things without replacement and where order matters. So here is our formula. We have N factorial over N minus R factorial. And factorial is where we just multiply. So it's like 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That would be 10 factorial. So examples of a permutation: picking a team captain, a pitcher, and a shortstop from a group. Picking your favorite two colors in order from a color brochure. Picking first, second, and third place winners. So that would be like electing president and vice president of our student body. So whoever's president and whoever's vice president, it would be kind of different if they were flip-flopped. So that's one way to think about a permutation. A combination, it's a set of objections in which order is not important. So here we go. So our formula, it's a little different. The only difference is we're going to have R, the choice of R things. So that's how many we're picking. It's going to be outside of our parentheses as well, the R factorial. And so examples of picking of combinations: picking 3 team members from a group. So we're just picking a couple of team members. It doesn't matter what order they're in. Just picking 2 colors from a color brochure, doesn't matter what order. And picking 3 winners, we don't care if it's first or second place. So instead of electing a president and a vice president, that would be, deciding on a committee of 2 from our student body. And so one of the things that you're going to notice when you do permutations and combinations is we will always have more combination when we do a combination than when, sorry, I said that wrong. We'll always have more when we do a permutation than when we do a combination. So keep that in mind. Your answer should be much higher for a permutation if we use the same number of options and the same number of choices.